Welcome. Today I'm going to talk to you about how to outsmart a mathematician. Um, and I sort of found it sort of amusing when I was putting this together. But as we progress through the presentation, I'll make some more comments as we go along the way. Okay, so what do we mean by outsmarting a mathematician? It's basically one mathematician having a conversation with another mathematician and showing them um, a way of doing something. So let's begin and see how we do this process. Okay, so what we want to do is establish a foundation. And so we started as what is an axiom? It's a statement or proposition which is regarded as being established, accepted, or self-evidently true. Okay, and what we now have to do is find some axiom that we want to prove or refute to see how this process works. So what the challenge is that we're going to ask the question, is a negative number a counting number? Okay, and where did that question come from? Well, the question came from the axiom or the definition of counting numbers. Counting numbers are known as natural numbers or positive integers, are the numbers used to count physical objects starting from one. Okay, now, when you read a statement, you have to understand it. And understanding it, you start with having the mathematician explain what it is. Okay, so when we count things, we start from one and move up. The idea of having less than none or something or a negative amount of physical items doesn't make sense in the context of counting. Okay, and that now gives us where the question came was, is that incorrect statement and is a counting number a negative number? Okay, so now we go to the next step. And the next step is we ask questions. And the first question we ask, is counting an addition process? And the answer is yes. And later on, you can read that in more detail. Can we count backwards? The answer to that one is yes. Okay. At this stage of the discussion, we have the mathematician hedging on what the meaning of counting is. His explanation for counting numbers relies on counting to the right. That's where the explanation had us understand his viewpoint. So the first question we asked, is counting backwards a subtraction process? Yes. And that was basically came about from the fact that we established that counting was an addition process. Is adding a negative number the same as subtracting a positive number? And the answer to that, again, is yes. So at this stage, what we've done is we've already done the refutation of what was said by showing that the definition of counting had to be both forward and backward. Okay, so what we do is again is review, and then we can see the argument process more completely. We reviewed by having the definition of counting numbers repeated, and then we had two steps that we asked the mathematician, how do we count things? And the next step was whether it was an addition process. These were the arguments that he gave that supported the axiom. Okay, so what we established is counting backwards is a subtraction process, and that adding a negative number is the same as subtracting a positive number. Those were the refutations of what he was, and essentially we won the argument. What does winning mean? Winning is a matter of opinion. Okay, mathematician or the person who we're having the discussion or debate with still will be satisfied with what he had. So what we look at next is, what was the thought process? Turns out, in order to do that, we use a geometric approach where we have tangible things that we can touch. And what the mathematician tried to tell us that was that negative things and zero we couldn't touch. Okay. And so the weakness of the geometric argument is the limitations or the specific applicability. Okay. So now we redefine what negative counting numbers are. All integers, including 0 and negative numbers, are counting numbers. And so we've redefined the definition. Now, you would like to argue something in a person's own terms, rather than go to, say, an algebraic approach as we've used here. So let's get to something that would seems to be tangible. A teacher walks into the classroom. He counts. There are 10 students, just like the original axiom had to say. He then counts the number of students who are not there. Basically, he knows how many students in the class. He goes through and sees which ones are not in the classroom, and he counts them. Okay. When he first entered the class, there were no students there. That's a count of 0. Okay. How many students are there in the class? Well, subtracting a negative number is the same as adding a positive number. So 4 students that weren't there, plus the students are there, are 14 students in the class. Now, things can be looked at more than one way. So if you can find another way, that gives a little bit more emphasis to the argument. So I'm going to use another geometric approach, except I had to be a little bit creative. I was familiar with slide rules that are used for multiplication. So it was fairly easy to come up with a slide rule for addition and subtraction, because basically the slide rule for multiplication is based upon an additive process. So how does the slide rule work? Well, in order to add, say, 2 to 1, we take the lower slide board, slide the 0 until it's under the 1, and then we count over 2 places. And we look up on the top slide, and we see the answer 3. We didn't need the bottom slide to do that. We could just go into 1 and go on 1, 2, and got the answer. Okay, now to add a negative number, let's say we want to add a negative number to 1, because that happens to be where the 0 is. We count over 3 places because we're adding -3. And we count to the left. 1, 2, 3, and we look up on the slide board above, and we see the answer -2. Okay, now the first time we did it was to get confidence in that the slide rule worked on things that we don't think we understand. And then we went and used it, using a similar process with it to go in the areas we don't understand. Okay, and that's it. You don't even have to be good at mathematics to follow through on this proof. It's basically understanding how to count. The only little question that came in there was how to deal with negative numbers. So you would have to go more on that. So hopefully try this out on your teachers or friends and see if you can convince them, because it's one thing for me to convince you, you have to convince yourself. Thank you again.